Okay, let's now break down how the OPC DA model works, focusing on its client-server architecture. So on the field side, the OPC server connects to field devices such as PLC, DCS, and field bus masters. It does this using its device's specific drivers. So for example, for manufacturing like Siemens PLC, uh, will be using uses different driver than an Allen Bradley PLC. Okay, so this is on the field side. Okay, we have dedicated device drivers. Now, once the data is collected from the field, so once the data is collected, data collected from field, the supervision side comes in. So here in the supervision side, we have the OPC server, and this server, what it does, it exposes uh, all those variables to and make them available to exposes to the variables or the field data which we select, okay, to the external system. Okay, now these external systems are basically OPC clients, such as, for example, HMI or SCADA, or even some monitoring dashboards. So a key part of this thing is of this thing is mapping between the internal variables and the field variables, and which the standardized the OPC makes them available to the network. So this mapping is basically is usually configured through a local interface. This mapping is configured through a local interface, meaning, for example, there is someone who is setting up the OPC server, and he or she will define how the data from each tag or the register uh, will get will be visible to the outside world. Okay, and the beauty of OPC DA is that it hides the complexity. So it hides the complexity of the underlying devices. From the client's perspective, they just request data. Okay, so OPC DA basically it also hides the complexity. And that's why this part is key, because it handles all the complexity. Okay, this handles the mapping complexity, configuration, and as well as the mapping complexity. And then the benefit comes here, that the OPC-DA hides the complexity of the underlying devices. And from the client's perspective, they just and the client is only client just cares about the request, requesting the data, and without needing to worry about and don't worry about, and no worries, don't worry about the actual field protocols. Okay, so it provides us so the DA model provides us like a unified and a standardized standardized interface, okay, between the real data uh, and the supervision layer. Okay, so this allows to talk to diverse systems to work together in seamlessly. Okay. Okay, so before the rise of OPC UA, let's talk about some the traditional OPC communication between, which was built on the two core technologies of the Microsoft, the COM and the TCOM. The COM stands for the uh, common object model, and the DCOM is the distributed COM. And COM is basically a way of different software components to talk to each other on the same computer. Uh, so if an OPC client, so we have the same computer, uh, okay, same computer, and we have the softwares, two softwares, they can talk to each other. Two softwares talk to each other on the same machine, and this is done through the COM interface. So if an OPC client and server both are running on the same machine, the client can access the server's data using the COM interface. Okay, so the same client has the OPC client server plus OPC client on the same machine. Okay, so they talk through the COM interface. And it is also possible that the HMI software might be acting as the OPC client. Okay, HMI installed on the same machine where the OPC server is running, and OPC server is talking to the maybe the PLC. Okay, to the PLC outside. So in this way, the COM is efficient. Okay, no problem. And the benefit is there is no worries about uh, uh, the firewall. Okay, and it handles efficiently. Okay, no network relay. So with the COM, what is the benefit? Uh, no network delay, as well as no firewall issue. Okay, but the thing is, it is on the same computer. Now, the DCOM, the second, now for the TCOM, this stands for the distributed COM, and this is where the OPC client and server are running on different PCs. So we have a PC1, okay, and then we have another PC2, and they are connected through the network, some network, and they are running on two different machines. Okay, so maybe we can say that HMI or SCADA is on one PC and OPC server is on another one. So DCOM allows communication between uh, through the DCOM. We can communicate between these two, the PCs and the softwares. Okay, so this is great, but it increases the complexity. Okay, so complexity increases in DCOM, and also the other things, for example, the firewall configuration. This is the most challenging. I remember firewall configuration is the most challenging thing. Even the if you change the Windows operating system, so that was a problem. And then we also have the latency issue. Okay, and on top of that, yeah, it is not that sufficient as the COM. So the COM is your COM is simple. Okay, and it is fast. And the DCOM, but and the DCOM expands to the network, but it has uh, it requires cost in terms of costly setup, okay, and configuration, and there might be some reliability issues sometimes, okay, due to the network. Okay, so that's one of the reasons the industry, you see, it is heavily dependent on the Microsoft. So that's why the requirement. This is the need for this was the need for platform independent and firewall friendly solution. Okay, so this is what we will be exploring in next few slides. So let's continue on the OPC DA. So by now, we have seen how the OPC DA laid the foundation for the interoperability in the industrial automation. It became popular quickly and was widely accepted by vendors, system integrators, and users. And uh, basically, the OPC Foundation is has now more than 300 member organizations, including the major players in the system integration and automation and the research. So over the time, uh, they also developed some additional uh, uh, the models, okay, in the classical. So we will go and explore one by one. So the first we have OPC AE. This stands for alarms and events. This model is used for managing time critical information. For the time critical information, such as alarms and events, okay, and operator messages. Next is HDA, HAD, data. This is HDA, historic data access. So in the historical data access, as the name suggests, it is basically this model helps to retrieve past data, and history data is very important because, and this is very important that in industry, if you have access to this data, you can build um, AI models, and which are like gold mine. So this is people don't are not appreciating, but this is like a gold mine. Okay, and and this is essential for the analysis and diagnostics. Okay, this is essential for diagnostic. Okay, and analytics also. Finally, we have OPC UA, and which we will go in more detail in the next slides. And OPC UA was originally, it basically what it does is it unifies, okay? It unifies and extends all of the previous one into one framework, which is very suitable for our current needs. Okay, so this is future ready and very good for for Industry 4.0 and IIoT and digitalization. Okay. Okay. So even though these standards started in industrial automation, uh, it's very interesting that they are now very relevant to the IoT environment. So basically, it evolved from we can say that the OPCs they evolved from operational technology industry, but they are very much relevant to the IT field of IT or IoT environment. For and uh, and the benefit is uh, we can deal with the data, huge amounts of data, and also the real time uh, processing, and this helps a lot in so in overall in the manufacturing or smart manufacturing, these OPC models is still offer a reliable backbone for data exchange. Okay, so in short, what we can say is this is they can provide they provide or they can provide a reliable sort of like data um, exchange backbone. Okay, okay, all right. So next, let's look at closer look at the DA. So let's this stands for data access. Okay, and this was the first major OPC. So this is again, this is the first major OPC specification. Okay, this is first, and its main job is to enable the data exchange between the OPC server and one of its clients. So on the server side, the OPC server gets the data from the field through the PLCs and DCS systems using special drivers, dedicated drivers, special drivers on one side. Okay, on oh, on one side. Okay, and using the special drivers for protocols like Modbus, Profibus, because it has to talk OPC on one side. It talks to their these drivers. Okay, OPC server, and these drivers ensure proper communication between the overall network. And once the data is collected by the server, it is organized into OPC items, and these are essentially the field variables. So these are basically the your field variables which are now available to the OPC uh, clients. Okay, so this may be some kind of like a temperature or pressure or motor status. Okay, but now they are available too. So this may be the temperature of a furnace, temperature of a furnace, or flow, okay, or a level in a tank. Okay, anything. Okay, so these will, but now these are available to your OPC clients. So the clients, OPC client, can now access these variables, field variables, as OPC items. Okay, so the client can then connect to the OPC server and browse through all the OPC items and access and monitor them. So for better structure, OPC allows to group them. Okay, so it group them into So these items are grouped into the small groups. Okay, so this makes the data handling much, and this is all done for basically the data handling. Okay, right. So this makes the data handling much more efficient, and also the structured, especially when you are dealing with, like, for example, hundreds or thousands of variable. Okay, so in that case, this the structured way is very important. So you have to group them. Okay, thousands, because there are thousands of DAGs in the industrial setting. So overall, OPC-DA gives us a clean way to get the live data, process data from the HMI. So the benefit of this is it helps us to get, okay, uh, 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 um, in a clean way, in a clean way, all the live access to the field data. Okay, and then we can bring this to the HMI or over a SCADA or a dashboard. Okay, or any other, or any even on the mobile phone, any client app. Okay, and even it is possible to get it on your mobile phones. Okay, and while you see the all the complexity down the real complexity of protocols at field level. Okay, so it is far away from you, right? So this slide illustrates the internal uh, architecture. Okay, let me write it: internal architecture. And communication flow of the OPC DA model. Okay, so at the bottom we have the field controller at the bottom, such as, for example, the PLC and the field bus, or the DCS. Okay, and this is your sensors, actuators, and real plant. Okay, so at the bottom we have the field controllers such as PLCs, field bus devices, DCS, and these are actual hardware components producing and receiving the data. Okay, so they are producing and receiving the data. The next OPC server here is this OPC server, this whole thing. Now the OPC server shown in this middle is where most of the intelligence is sitting to deal with the data, and it interfaces with the field devices using the dedicated drivers we are using here, and they perform um, the access optimization, and also it manages into the groups and the items. It has the field interfaces, the device drivers, access optimization, management of the groups and items, and these are the data points exposed to the cloud, to the client. Okay, the server offers a core DA interface. So this is a core sort of interface that we have. DA interface. This is mandatory for basic data access, and in addition to that, we also have some optional. This is the core, and these two are the optional optional interfaces. Okay, optional interfaces. One is the historic data access, and the other one is the alarms and events that can add the for optional for added functionality. Sorry for slow writing. There is some problem on this software. Okay, so these are indicated as because these are optional. On the top of we have the, if you see the on the top we have multiple multiple OPC clients. Okay, so we have multiple OPC client on top, which could be, for example, it may be SCADA application, or it may be some HMI. Okay, it may be SCADA, it may be HMI, or it may be a dashboard. Okay, and these clients are connected over a supervision network that request the data and interact with the exposed interfaces. So there is also a link to here, the database. Okay, so we also have a database here, a link to the database, which allows the to store the historic data, historical storage. And this is very important to do the analysis, and very helpful in these days to make the AI models. And this is where the AI model or the feature engineering, for example, feature engineering, you have to go and see the history. Okay, so this is very important to learn lessons, for example, or see in the past. Okay, this is very important, very important. Okay, so overall this diagram helps us to understand how the basically what this diagram this diagram helps to understand how OPC DA manages a real-time flow, real-time data flow, and its organization for multiple clients. Okay, for the standardized and scalable access. Okay, so right. So this slide explains the three core. It explains the three core communication mechanisms. Okay, so we have three core communication mechanisms, three core communication mechanisms in the OPC DA. So which defines how the OPC client and server interacts. So first we have the synchronous calls. In this method, the client sends the client will send a request. Okay, it will send a request, like for example reading or writing a value, and waits, sends a request and then waits for the server to respond before continuing. So this is a straightforward, but may block the client if the server takes time. Okay, so in case because it has to wait. Okay, and the second we have the there is an issue here. Okay, so it may block client, may block client if server delays. Okay, so this is first. Now the second is we have the asynchronous calls. So in the asynchronous calls here, the client sends a request but does not wait. So the client will send request, but it will not wait. Okay, and but doesn't wait. Okay, and it continues doing other tasks. So when the server has the response ready, it notifies uh, it's from here. Here we have server. Here we have server. Okay, here, this is our server here. This is our client. This is our client here. First case. This is the first case. This is the second case. So the client sends in asynchronous call. The client sends the request, but does not wait and continues doing its work. And when the server is ready to respond, it will notify the client. So this is very useful in the real time scenario. Real time. So this is good for the real time scenarios when we can't afford delays. Okay. Then lastly we have the event subscription. Very interesting. This allows the client to subscribe to specific data points or the OPC items. Okay, so if any of these items change value, so this is basic trigger based. This is a trigger based, and whenever something changes, the server triggers like the server is looking at it. It has all the data. Okay, let's say some kind of a specific variable data 1. So if data 1 is constantly and then it changes, when the data 1 changes, the server will send like a callback or to the client. Okay, because client has a event subscription. So this is an event on this data. It changes, so the event will trigger the a callback to inform the client. Okay, so this is efficient, and because it avoids the polling and gives the real-time upsets. So this is the efficient one. Efficient. So these mechanisms make OBD. You see this. So what we see here is this is flexible. Okay, it does not mean one thing. It is flexible data model, and it is suitable for both periodic monitoring as well as for real-time control systems. Okay. Okay, so this is the last slide in this video, and after that we will have a separate another example. So in this slide, we will talk about the core components that make up the interface. Okay, so last time we talked about the mechanisms, and here now we are going to talk about the DA interface. So there are three key objects you need to understand. The first is the OPC item. Okay, and think of this as a variable from the field like temperature or so OPC item. So just think about just like a variable. Think of uh, a variable. Okay, from field, and from field, for example, it may be a temperature, it may be a pressure. Okay, or even the motor status. Okay, turn on, off, whatever. and that is made visible to the network. So each item has three main attributes. So um, if we take pressure, for example, it will have three things. It will have a value, it will have a quality, and also it will have a timestamp. Okay, so there are these three variables, these three attributes. Okay, so these are the three attributes to each variable. Okay, uh, the quality the quality will tell us whether the value is reliable. Okay, so it is valid or it is reliable. And then the timestamp will show when it was last updated. So we have a value, we have a quality, and then we have the timestamp. So these are three attributes together will define the variable. So next we have OPC group. Now this acts like we can think of like a container. Okay, so OPC group is just like a for container for multiple OPC items. Okay, so it allows the client to organize, and it is basically to organize the items into for any batch operation. For example, you can read or write a group of items together, set their values. So we can do like a group sort of group activity or operation, activity or operation. Okay, so maybe it is like update. Okay, so there may be a specific update rate together, and even you can assign some kind of like callback function, callback uh, function to a specific group. Okay, for some kind of like uh, asynchronous interaction. So this grouping helps us to configure the communication more efficiently. Okay, so this helps to do the communication configuration efficient. Okay. Finally, we have this OPC server, and the OPC server is it's basically a software that is running in the background, and that is managing all of this stuff. It's responsible for making and this server is responsible to allow us to make the items and the groups, basically the OPC server, and make it available to the OPC clients and for handling the data exchange between the OPC protocols. So this represents all the software process for the interfaces. So these three elements, item, groups, and server, work together to ensure seamless and flexible access to the real-time industrial data. Okay, so I will stop here, and we will continue our lecture in the next recording. Thank you very much.